What's up, guys? We're going to look at Advent of Code day 11. I'm still catching up, so I might do 12 today as well. We'll see how it goes. The theme for today is things that I did an okay job on, but I know there's a better version possible. So I'm going to point out 3 things in this video where I got it working, and I know kind of the general idea of how to do it more optimized, better, but I'm not quite there yet. So the plan is sometime over Christmas break, maybe I'll come back and do the cool version of this. Anyway, the challenge is monkey in the middle. We've got these monkeys, they pick up an item, do something with it, and then throw it to another monkey. So we have to track all these items as they move and as they change. We start out with a lot of information about each monkey, and that's the first challenge, is parsing the input. And what I did was not the greatest way. So we get the input like this in big chunks, and then what I was doing is the same thing I've been doing in the others, line by line. And that's a problem, because then I have all these if statements like, oh, if it's this kind of line, we do this. If it's this kind of line, we do that. And so it's really not taking advantage of the fact that we know what it's going to be. Right after a starting line, we know the next one is operations, and what I should have done is treat it as one big chunk. Right? I could say like, oh, we're going from monkey to an empty line, and then we get the items, and we know what's going to be next. We don't have to say if, as if it's some, complete surprise. We kind of know. So that's one thing I would improve, is that this time I wouldn't stick with my habit of going line by line, even though it's worked for all the previous exercises. I would instead, break it up from like the sort of the double new line, the /n/n. So that would be chunks of monkeys, Ben and Jerry's, So, however, I got it working, and we parse this stuff, and you get the numbers the monkeys need, the operations they need. And that brings us to the next thing I want to improve, which is the way we did the functions. I just sent pieces of info, like, oh, there's a plus, and there's a 9, and you end up making it +9. But I know there's a better way. I'm sure there's a way to use sort of higher order functions and pass in the method, or what would be the method, all at once at the beginning, rather than doing this ugly stuff every time. So what I tried at first was to make a lambda and to say like, oh, operation equals lambda x something something. But the problem was lambdas don't work the way I thought they did. Here I made this little example to show. So let's say you've got an object and you've got some other outside variable. I called it a dependency because that's what it is. And so let's say you make a lambda and you pass it into the guy, becoming a method of that object. So what I thought was, okay, the independent variable, the parameter, the thing that's in the lambda before the colon, that is evaluated on the fly. That's like sort of runtime thing. And I thought the other stuff would be defined earlier on, and it would be locked in as a constant. But it turns out that's not the case. They're all almost global in that sense, where they're like, when you say x plus dependency, it waits until you ask. So if you have dependency 5, it doesn't get locked in as 5. It becomes whatever it is in the moment. So when I say guy method of 1, it says 1 plus 10, even though 10 changed after we defined the method. So that's what was killing me at first, is I tried it by passing in a lambda based on the end of the line, like, I think it was like this or this, and it wasn't working because it was trying to find that later when we do the monkey stuff and not at the beginning when we define them. So I need to learn a way. I'm sure there is a way to lock in a certain constant. Maybe you don't use lambdas, maybe you just make a classic def function and pass that in. I don't know. The answer, however, works the way I've got it, which is pretty ugly. It does work, and so when I run this, it gives me the initial state of the monkeys and then the final state, and then my answer is, what they ask for is pick the 2 monkeys who have done the most, who have gone through the most items and inspected the most, and then multiply those 2 numbers together. So I had them just keep track, +1 every time you do this. The inspect thing, I'm fine with that. I actually did a good job with that, I think, and this is not going to be a part that I come back and overhaul unless I just have a new idea. You say while you have items, because it goes through everyone every time, and then we do this pop, and this while pop thing is a way to avoid the classic problem of usually when you're going through a list and you change it, like you remove if you remove some item from the middle and then you go to the next one, is it really the next one or did they shift over? This doesn't have that problem because you just take one off and you're only looking at one, do something. Take the next one off, you're only looking at one, do something. And so they have this rule of like, okay, the monkey picks it up, does an operation, and then we divide by 3, which is mercifully keeping the numbers small, right? And then we test it, toss it to one guy or the other. I also made a little repr to give my test logs some info. And that's great, that works. However, part 2 is when it gets spicy. So part 2 says, all right, we're doing the same thing, except, oh, what if it was 10,000 rounds? And you go, oh, that's fine. And in fact, it is fine. You can run that and get an answer, but that's not the only thing. It took a second, right? It took a second. It was a little chunky, but it got there. Now, the other problem is they say, you know what? They don't divide by 3 every time. So if we took that off, well, I'm not going to show you. I could hit run and it would just get stuck. It would just, I'm not actually sure what the final problem is. It could be that the numbers are too big and it's trying to store something insanely huge. Although, I don't know if Python has a limit on integers. It might be fine. Or the other thing is it might have a problem doing the operations, and especially my guess is the modulo. I don't know, maybe it's the plus, but I'm guessing that the modulo is the one that's slowing it down. So this is the third and final thing I need to improve. I haven't finished part 2 yet. I'm gonna get it, and my guess, I haven't looked at other videos. One day I did look at somebody else's before I did mine, and that was fine, but I'm trying to do them blind. My guess is that we don't actually store the number. We're going to store like transactions. We're going to say like, oh, well, it is squaring, but we're not actually going to do the squaring because it might be too big. Now, squaring seems easy because every single test of the monkeys is divisible. We never have to do anything else, so it's always divisible. So that's probably a clue that we're using that for the optimization. Now, if you square something, it's still divisible by the same stuff, right? Like 5 going to 25. Well, it's still 5 and 1. Now, you have that 25, like the top end changes, but only the top end. I'm pretty sure. I haven't thought about it. And that's true in general. If you're multiplying by another number, well, you just add that to the list of factors, right? Like if theoretically you have a list of factors, and we just add one more, which is not as bad as storing a massive integer. Now again, that top end, like if I have 5 times 13, well, my factors are 1, 5, and 13, it's not that bad. But the answer of, 78 or whatever, that's a new factor, and we have to keep track of that. Maybe it doesn't matter. The hard one, though, is the plus. I think squaring and multiplying by random stuff is fine. I think I would be able to figure that out. But when you do plus, I'm not sure if we can just easily optimize that away. If you imagine 5 plus 1, well, now it gets a couple new factors. It gets 2 and 3, and again the top end 6. And if you have 25 plus 1, well, same thing. Now it gets 2 and 3, and the top end is the is the hard part. Maybe we can just ignore that and just say like, 26 doesn't matter. 2 and 3, those are important though. That would be my guess, okay? My guess would be that what's slowing it down on the 10,000 without dividing is that either storing huge numbers or probably doing modulo on them. Or even if it's the other operations, we can reduce that by not actually doing them, by just like keeping a list of transactions and saying like, okay, we are multiplying it. Let's not find the answer, but just know that it's there. Like in algebra, if you write 17x, you don't actually have to find x and then multiply it by 17. You just know that that's a thing. So that would be my guess. I'm going to think about it and come back sometime over Christmas break and do this one in a cool way. Because right now I feel like I got it, but it's kind of an ugly way. I want to parse the info better. I want to use some higher order function wizardry, and I want to optimize the modulo / big boy numbers. I don't know how Python does modulo. Maybe it's already super optimized and there's nothing you can do, but I'm guessing we can figure something out. Otherwise, why would they add it on the challenge? Anyway, that's it for now.